secure service to service connection.
ये
Most
हाँ, एक
important
बार ये
thing,
वाला
most
ये ना?
companies is
हाँ।
like security.
मेरे को पिन करो एक बार।
Whenever you are doing the communication between the services, services, so there should be some security from the like you can add it afterwards or you can do it from start only. But I guess sidecar version of
I
the
airdrop
issue,
receiver
it was not providing that
Okay.
stuff, like security was not provided.
Sure, he pinned है.
हाँ मैं पिन पिन है ना, फिर वो कहाँ पे डिस्प्ले हो रहा है?
वही स्ट्रीम वीडियो ऑन यूट्यूब का लिंक
नहीं, वो कनेक्टेड दिखा रहा है ना।
कनेक्ट हो गया.
So this is the thing, like security is the most needed. So service is one part of the thing which will make your simpler for it. Another thing is traffic control, shaping and shifting.
वो तो है. हाँ, तो यही तो है.
वैसे model आएगा,
Right?
वैसे
यहाँ पे
application layer, transport layer.
बस ओरिएंटेशन.
So application layer kind is various things, traffic, inside traffic shaping, and if you want to send some packet from one server to another service, and go to like filter it to shift it from one service to another, and you have to do the various things, right? So this is the service mesh which
अच्छा, this is
easily.
अंडर
So after that, there is the intention based access control policies. So when in like if you are going to some environment and stuff, so when you deploy the Kubernetes cluster, right? So once you have the Kubernetes cluster, you want to add some, let's see, you want to add some application. And then you want to assign some.
मेरे को लगता है ना वो उसके आगे दे दो, रोहित के आगे
नहीं नहीं
तो
नहीं,
ये पेन
लोग दिखेंगे ना इसलिए।
Dasha, is there any way we can use OBS? Like, but it's here, so
You can directly
But
attach and
through OBS, you cannot let another people to join. You need a client like human.
but okay, yeah.
तूने बोलो जोशो जोशो कर दिया चलो
It is going to everything going to the ingress and egress data. So this is kind of as I told, like business logic kind of. So that is done by this thing. And it still is something as a sort of service meshes are there. So as you see, like this is little complicated, right? So whenever you want to do everything, it is going to this proxy, and then afterwards do the ingress, and then if someone is sitting there, so this connection is little too much tired kind of thing, and it takes around like so when you are doing this combination to this, like your annual proxy from service A to service B, so it is like 1 millisecond, then 1 millisecond, and 1 millisecond. So your 2 milliseconds are your latency. So when there is big kind of a thing, what we do. So this is the diagram. It is about these services and the integration between them. So it is like what is the certificate, how it goes, so policy. So when you want to the policy assigning kind of thing, translation kind of thing. So it will do to the IM you know, right? Access management kind of. So it is the one who will provide you some authentication policy and kind of thing, and you assign that, and after that it will get your security kind of thing, and then it will provide to the various things. So matrix is kind of a thing, same only, but I'm not focusing on that kind of thing because it is easy, but that was a kind of a tough. Try to understand this, like get a photo or something, and then you can ask me doubts when you are learning about this thing. I would surely reply you and try to make you aware of this. So current sidecar model is like this. So node is there, various nodes are there, and inside there is a service, and inside that there is application and your process. So that is your sidecar. So this is happening if you want to can do the communication between the application one and application 9. It is that what I showed you. But if it is inside the job one of the application one and job 9 of the application 9, so what will happen? So that is kind of a number, right? So it is in the service mesh world, but when it comes to the other world, then it is all then it is little tough there also. So that's why service mesh was introduced, but here it is also tougher. So what if we will do to reduce this sidecar kind of thing? So let's learn about this thing. So there was like overhead cost as I told, like that proxies are attached to different proxies to different applications. So there's cost, operational complexity as I told, which is complex as you see, and there is performance. Performance will be talking about this thing. So, well, guys, whenever you, this is kind of a thing, it will look to you, like you can't see when you deploy these things, you can't see like what is happening inside. So, what you will see is kind of a thing. So, if you are deployed to application, you will see like you have some envoy proxy as one core extra, and your services as one core. So, this is the sample application book info file deployment. So, whenever you are running out HTO, you will get this sample by default, and this is the thing. This thing will happen inside. So it's like one step out. So there is challenges everywhere, which we talked about. So operational complexity, as we told, like resources to add any application, it is tougher. Application mesh aware.
I have to set up this here I guess
Not related to what I am saying. But what happens? I wanted to convey here like it is very complex, and when mesh is not aware about what is happening inside, so sometimes it is hard to understand.
yeah
नहीं थोड़ा डिस्प्ले की तरफ
So as I told, like
sees this
if
would
you
be
want
very
to look
informative.
at communication between the application one and application two, it is 1 millisecond, 2 milliseconds. So you have like 2 millisecond wasting, and latency is too much. So if for one job it is not that much for you. But when you see for the different kind of services and different communications, it is really too much time, right? So that's what I wanted. That's why I showed that diagram to you, not to make it with the things, but this is happening in the inside world. So cost, everywhere, and what proxies are there. So different applications, the different nodes, different proxies are there. So
I think this is
cost will
creating
be
uncomfort for
No,
you.
no, no.
You can sit there.
so
Not
future
at
of
all, it's
service
fine.
mesh happens in and around the data plane. So everything is applied outside that
Is there a
service
problem on the
and
angle
data
because
plane.
of me?
No, no.
Sorry, service and network proxy, which we talked about. So in the future, what we will do, eBPF, I know like many people are not aware of the same, but it is one of the revolutionary firmware technologies launched. Try to understand what is happening in the eBPF world. So in the Q1 also, everyone is talking about the eBPF. They had the eBPF day also, I guess. There was eBPF conference also. So this is kind of a thing which will really get like buzz around in the future. So if you are like early contributor into these things, you can understand like you will get the jobs and internships directly. Like you will not need to apply to the jobs also. So same thing is happening around the service mesh. As I traveling to various cities and stuff, I have noticed like service mesh and HCO and Kubernetes, people are not that much aware of the same. So if you are early contributors into this thing, so you will really get hype, sorry, not hype, but you will get people who want to understand you kind of thing. So I would really, this was not related to this presentation, but I just wanted to share because you are students and you want to, it's like you want to secure your future. So that's why I just recommended one thing. So what happens? Data plane is where the innovation continues to happen, as I told. So and that and IMOPS is something sidecar thing. So your transport layer and one kind of a things is going inside that only. So API connection. So now you can see like HTTP and kind of thing. So if you know your OSM model, so there is HTTP comes inside with which one? Which layer?
Application.
So that is thing, and there is a WebAssembly also. So WebAssembly is something. It is nice only. Like you can also learn about that thing. Extending the data plane, as we will talk about the same. And eBPF is something in the future. If you want to optimize whatever I am seeing today, then we can do it with the eBPF. I can guarantee it from now on. So in the future, there can be a version where like sidecar, it's like sidecar will be removed, it is removed, as I will tell you. But in the future, we want to optimize that thing also. We will do with the eBPF. So yeah, let's introduce what I want to bring about. Uh, so Istio Embedded Mesh, it is launched by Solo and Google. So here the lead contributors are from Solo and Google. So what happens? It is the open source contribution to the Istio project. It is used data plane added to it. Right? So when you do, no, we will show the demo some problem. So it is just a sidecarless data plane added. So you want to aware of that only. Then there is various of challenges we discussed. It is removed by that thing. So what it is and what it is doing. So see here. So there is it is slicing that two layers of the STO. So what happens? Secure overlay layer is your something which will handle your transport kind of transport layer things. And there is L7 processing layer which will happen for the your application. So whatever you want to, just everything, main things like security kind of a thing, everything is done here only. So secure overlay layer. So that is important. So here you don't need the sidecar kind of thing, it will be done directly. So I will show that. Traffic management, TCP routing, security, mutual TLS connection kind of a thing. So observability, TCP matrix and logging. So everything is done inside the secure overlay. And L7 layer is something where you want to inject your void injections and then rate limiting, various things you want to do. So circuit breaking, if you have heard about this thing, so that is also happening in the L7. So let's move forward. So as I told, so what happens? Previously, what was happening? Everything was like yes. But now, what will happen? Your node has some services and it will directly move from your services to the Prometheus. So as we told, like we can use the BPPF for gathering additional data in the future and we can do the stuff. So this is the current issue ambient model. So what happens? As you see, like there is some, this is the three tunnel which is sitting outside, and it is doing the everything inside your node. So you don't have now proxy to attach to various services. You just have one three tunnel which will be directly connected to your control plane, and everything will be happening inside of that. And if you want to communicate within the application and all, it will directly connect. You don't need proxy attachment. So when you need the L7 things, authorization policies kind of a thing, you will get it from outside. So it is provided outside. So we reduce it, cost is reduced, one challenge reduced. After that, as you see, this is the one thing we were talking about. Like previously, there was pods and there was proxy and there is the pods of your services. So now it is just one proxy, which is your three tunnel, which will do everything for your nodes. So this is our new data. So it is reducing your complete. As you see, like there was 3 version CPUs were needed previously. Now it is just a 0.2. How much it is reduced, right? Memory and kind of thing. And if you need the L4 plus L7, if you want, so then you can just add one inside and which you take from the outside, which I told. So 0.3 will be added, and it is just 0.3. So comparison is too much, right? So after that, memory was 396 and it is just 384 and 6. So it is big issue which is solved, and that's why I wanted to convey it to you. So this is the block where you can check in detail, like how your cost is reduced for your working. So you are from the company side kind of thing. If you are using the HPO, so if you want to move to the ambient, you should check this block because it will help you to understand like how your cost is reduced. So this is the latency issue which I talked about. So now it is just 0.5 millisecond. That was like 2 millisecond or 3 millisecond, right? And if you want the L7 directly, now it is 2 milliseconds. Previously it was 4 milliseconds. So yeah, you can get the photo of it. Like whatever we talked about, everything is in this image. So like zero trust security is there from the default. So whenever you don't need to add your policies afterward kind of thing and stuff, you can add it afterward also. But security is provided by default from the ambient. You don't need to provide afterwards and kind of thing. So afterwards, what happens? One important thing I miss. So what happens? Whenever you want to add application to your service mesh, so you can't add it in between. So you have to add it from the start, or you have to add it from the end, or you can't add it into the afterwards kind of thing. That's why ambient mesh is something you can add application anytime you want, and it will not restart your pod. It will directly start your pod. It's like it will directly connect, and previously it was just various things were you have wanted. So what's next? So as I told, like informatics and kind of thing. So eBPF we can add afterwards. So if you are running the eBPF kind of a thing, you can contribute to the future models of SQL and get the recognition and secure your future. So these are the various things, resources and things. If you want to learn about the ambient mesh, solo kind of a thing, and blocks. So these are the podcasts with the Google and Solo. You can learn about it. This is the hands-on training and certification. So we will try to provide the like this is the certification kind of thing. We will get the certification, and only few people have it. So you can get those other questions. So let's. I will try to show you some demo. Let's see. Don't know if this is in there. Okay. So let's. So I should have done this. Actually, this is Zoom version of the same. So what happens? Cursor will take some time to move here and there. So please bear with some. Let me do one thing. I have to build the cluster, and then we will talk. Yeah, it is installing. So what happens? Whenever you want to do the deployment of a cluster, it is not full. Okay? It is full. Actually, this is zoom out version. So what is happening here? I will try to tell you. So what happens? Whenever you want to deploy the cluster kind of thing, I would recommend like export it, and it will be like if you are working on some environment, if you can like export it, then it will easily to convey your connected versions of the multi-node clusters and clusters. So that's why I do the export, and then we are just introducing the find cluster. So find is something now famous for the Kubernetes cluster kind of a thing and all. So we are just using that cluster one name to do this cluster deployment. So not fancy things are in here. It is just installing the cluster, and what I mean, it is using some node image. So it is just pulling the layers, and node image is here, and then CNI is something I will talk about more in this demo. So what is CNI and all kind of thing. So control plane. So it is here this control plane. It is not HTML. So there is some storage class. So if you want to learn more about the Kubernetes kind of thing, so there are various resources available. You can go and learn about the Kubernetes on the YouTube and stuff. There are various people teaching about things. Kunal is there, Sayan is there. Also Nana, tech world Nana. So learn from them. So then you will understand like what is this thing, time, and storage class. So storage class and PVC is something to give you the whole. When you deploy the cluster, when you delete your cluster, like if sorry, not delete your cluster, you have application, right? Your sample application. But if you started that pod and you mistakenly delete it, so PVC is something like your I don't remember the full form, but PVC is visual virtual plane is something. So it is something which will restart your thing and directly. So you don't need to like be scared of the thing like you deleted your. So that's why this thing is there. So we are just joining worker nodes, and our demo will start from there. So this is the thing which is inside that certification. So try to understand, and you can get the go and try this hands-on workshop, and you will get certificate also from the. You will get some badges and on the plate. So this is check. So I check every time I run the check message to confirm like everything is working fine. So sometimes you will get your JSON error or something. So you can wait for this thing to run again, and you will get this thing. So don't get scared of that check that message, because it is just for the checking kind of thing. So we will get our istio CTL, which is the thing we need for doing our istio things, service mesh kind of thing. So we will get it from the official repo. So if you go to the istio document, so whenever you are learning about any Kubernetes istio kind of thing, go to official documentation, see that setup, getting setup kind of thing. Then you will see this installation and so go to the recent version, there is ambient present. So we will install that, and we will just extract here. So once the so we will just extract it by using the tar, and we will install it. So as you see, if you want to install the same, I am using your profile or like ambient profile. So it indicates like if you want to do everything on your Kubernetes kind of thing, you will go with your ambient profile. So that's why I use this. It is not that much thing. So what it will, as you see, it will provide you everything by default. So cternal is there. So previously Istio doesn't have this cternal kind of thing. Now it has. It is installing the Istio control plane. So here you will talk more about the CNN. So let me show you for the front audience. You can read it over here. So what is happening here? So it is installing that history to the Ingress gateways that feed another CNI plugin, everything is enabled. So we talked about the traffic filtering, redirection, and kind of thing. So traffic redirection and all things is done by your CNI. So if you want to learn about the networking and if you want to live that into your our new cloud native world, so what happens? You can go and learn about the CNI mode. There are some open source projects like Canal is there, there is Canal is there, uh, there is Castro, Cilium is there. So Cilium is kind of getting much hype today. So try to learn of this thing because CNI is something which will be your backend of your Kubernetes. So whatever you do, the traffic redirection and traffic packet sending and kind of it will happen inside this CNI. So this is really high high things I'm trying to understand this, but make it think it like this,
Like that. Nahin, nahin. Hi, Jack.
whatever
Hey, can you hear us?
How are you?
Can
Yeah.
do
Can you hear us?
turn off the mic?
Yeah, I can hear you.
वो वाला mic बंद कर दो.
Is it
Mic
clear?
stand बंद करो, mic बंद करो.
Yeah, it's clear.
Okay.
It's clear. So
Yeah,
we'll
right.
start your session maybe half an hour delayed.
फोन वाला mic बंद कर दो. फोन
All
वाला
right.
फोन वाले mic से आ रही है आपकी आवाज. चेंज कर लेना.
verify on the demo.
इसके ऊपर छोटा एरो है ना उससे.
Half an hour delay?
नहीं एक बार जैसे
this is nice to provide the environment, and it has no chances to it's like if you are giving the demo and sometimes your connection doesn't work, your net doesn't work, so this is nice. So here we will just use our, you will just namespace that label kind of thing. You will add label as ambient, and you will see like you don't need to add restart or kind of thing, and you will just assign it to directly to the application. So in this logs, you can see. So this is kind of how to say, but as you see, like there is a ambient, it is, yeah, it is here. So namespace default, and it is just disabling and assigning to various ports which was previously there. And as you see, like ambient namespace default is enabled in your ambient machine. So this we talk about the same. So talking more on the same thing. So demo set like kind of thing, I will not go into the same. But sleep and non-sleep, which I talked about. So here it is. So sleep will go through your Z tunnel. So now it is you don't have any proxy or something, right? So everything will happen to the Z tunnel. So if you want to do the application connections and kind of thing, it will go to the Z tunnel, and then your control plane. You don't move to the one proxy to another proxy and kind of thing. So it is directly moving to the control plane, your packets and kind of thing. And there is mutual TLS connection by default only, and there is config kind of thing. So Z tunnel is something which will establish the mutual TLS we talk about. But yeah, we will go to our demo. So we have sent some traffic to check like whatever is happening inside our ambient mesh. So let's see logs for the same. So in the logs, you can see like I'm not sure if you can see there, but as you see, like there is outbound tunnel and inbound HCM. So that is not very important, but where it is. Yeah, so no waypoint proxy is there. So it can directly tell you there is no waypoint proxies attached. So if you want to do that L7 policies kind of a thing, L7 connections and kind of thing, you don't need it from the start. So it is telling you that there is no, it is not there. So whenever if you are learning these things, try to go on the log side. You will get understanding like what you are happening inside. So it is telling you no way to proxy, no contracts is there. But yeah, we will do that policy attachment. So as I told, like policy attachment you can do. So we will. This is something you can do with YML file also, and you can do it directly from the command line also. So it is doing the one authorization policy. What is happening inside this authorization policy? It will doesn't allow anything. So if you want to do the packet connection services and kind of thing, it will this curl agent will not be able to access that website now. So this is allow nothing. So as we are setting this web API, we will set our ingress gateway, and you can check like display explained is unable to access that website because we have set some authorization policies. So let's do one thing. Now we can do one thing like application. Now we will set some policy where only your application will be accessed by your call agent will be sleep. So other than sleep, no one will be able to access kind of a thing. So this is like some kind of a base security you can get. So we have used this authorization policy and it is created. So now as you can see, if call agent wants to access that thing, it can access, right? But there is some next not sleep call agent also there, right? So if that wants to access this website, it is unable to access, unable to access. So this is one kind of best security you can get. So I guess I don't have that time or something, but I can show the next demo also. Okay, so what happens after this is just the L7 policies you can use. Like if you want to assign the L7 policies and kind of thing, and you have to do the like you have to do the L7 authorization policy. Like you want the application layers like HTTP connections and kind of thing. You can do it easily. Then you want observability and fault injection. Everything in demo you can do easily, and you can type these workshops out. So what happens here you can also get that certificate like if you are doing policy attachments, you will see like that certifications certificate for the user data extension will be shown here. And you can see.
Is on.
You can view the hands-on means like try it out here only. Yeah, so you can go on this thing and you can check like what is happening inside. So I guess I discussed everything. So this is just like terminal kind of thing. If you want to do it on your terminal, so this is K9s I use. So this happens in the demo or your on the terminal also it is same here. So thank you and we'll meet again for the next one.
Shubham. So we both will be talking about what is dev data and why it is so important now, right? So why we should think about DevOps performance or productivity, whatever we call it. So myself, I'm Joshua. I also emailed you, so most of them couldn't identify. So I'm developer evangelist for Merico and also lead evangelist for Apache DevLake itself. And I also started JD program, which is called Junior Developer Evangelist Program. So whoever you see, like the guys who are helping our Junior Developer Evangelist for Merico. So if you want to know about that, you can ping me later, or we can talk about it backstage. So what is dev data, right? So why we should think about dev data? So if we see this scenario where whole team of developers working together. So if you see like one guy is really productive and really happy with whatever he's doing, and the other one is frustrated, the other one is burnt out, and other one is worried. He has no idea what to do. So if you have you ever encountered this in your teams whenever you're working, collaborating in hackathons, or maybe in your work if you are working. So this is because of you cannot really uh, express what you are doing as a developer, right? So if you are into business and management, you can really update. Okay, मैंने ये किया है, right? I did this thing, so this worked. But as a developer, you cannot convert code into some meaningful information easily, right? So for that we need dev data. So what we need is what information. When there is a lack of information and lack of communication, we expect this scenario, right? So we expect this thing in every kind of team. So for this, if we look at the evolution of software engineering or tech in general, so this is this I sourced from Gigs for Gigs article. They explained about the same blog. So you can check that out. So basically, initially when technology like came into existence in late 1990s or early 90s, if you see, it was only accessible for some group of people, right? It started with some group of people, And after that, as it evolved, it actually expanded the reach as well. That art became a craft. Like everybody could understand it and can practice that technology, right? So you can learn any tool or framework and you can actually build things. It evolved in that way. Now, when it comes to today, it is evolving in the way of systematic engineering, right? Everything is systematic. Everyone can learn. Everyone can implement, right? So when things are globalizing or things are moving to different horizons, like everybody is accessing so many things and everybody can implement. So it also increases what? More data, more details, then more complexity. So what we are talking is about why we need dev data is because to solve this complexity, right? So now there is so much of development processes, so many tools as a developer you use on a daily basis, as a DevOps engineer especially. That means you have to track so many things as an individual, right? So for that we need proper, tracking to improve your performance. So some people may complain why we should measure the work, right? That's not a good thing. Like it is like you are targeting some people because you should work more. This is not that. Because as giving a little background about DevLake. DevLake is nothing but it's a productivity tool for engineering teams or DevOps teams in general. So where you can track lots of other DevOps tools in one single dashboard. So you are not tracking any individual here, but you are measuring the team performance and finding what is wrong in the whole development process and trying to fix it. As simple as that. So, so now there's a famous quote by Peter Drucker. So it's like, if you can't measure it, you cannot improve it, right? So everyone has to measure. Even if you are doing your daily routine, you measure the things, right? Are you doing in this much of time? Or you have to improve it. In the same way, as a developer, as a team of developers, measuring the minor details are really important. Like how many times the build is failing, right? How much time you are spending on fixing this issue, and if you are fixing that issue, is it going into production or not? If it's not going to production, then whatever your time you have spent is not productive, right? So you have to make sure you set your priorities as a developer. So you may use this scenario even in your hackathons or in your group work, but especially this will be useful for DevOps teams in companies, right? So where they have to set the priorities, they have to decide which is more productive to implement in the next release, let's say. So for that, we need DevLink. So, so DevLink is a tool where you measure stuff and you improve. As simple as that. I'm trying to be simple, nothing much complicated. Uh, so so if you go to devlink.apache.org, so this project is now incubated under Apache organization now, Apache Foundation, sorry. So you can check the website and see, what you can learn from the documentation. It's very clear, very easy to install. So Shubham would be showing us that. And also, if you want to become a contributor, you can join our Slack. So we welcome all types of contributions. So what are the use cases, right? So DevLake, the first and more primary use case of DevLake is we are implementing DORA metrics. We'll talk about it later. What is DORA? So DevOps research and assessment. So basically DORA is for DevOps research and assessment, which was initially introduced by Google Cloud. But there are so many tools which are paid. But for the first time, Apache DevLake is implementing open source, fully open source DORA support, so which has come in the recent release. So as most of you are students, right? Are you are working? Right? All are students? Okay, so I will talk about what will be useful for students. As a student, how will it benefit? So now you might be new to DevOps ecosystem. So Apache can be a learning tool just to explore the pipelines, just to see where the metrics are coming from, right? To understand the philosophy of DevOps. Apache can be a learning tool. Apache DevLake can be a learning tool. So we have 4 use cases. Especially, I will talk about what is useful for open source maintenance. So one of the, of course, the famous DevOps tool is GitHub, where we get all the information. So for maintainers, they can see how many issues are being created in 1 week. Let's say, right? If it is decreasing, that means your community is not active. As simple as that. So it will act as a community monitoring tool for maintenance because every data is collected from GitHub and DevLake is helping to analyze. So it's the same for development teams or product managers. So what are the things that needs to be set on priority, right? So we can integrate tools like Jira and stuff like that for product managers. And for data engineers also, we can implement some custom plugins. Like if you feel like, okay, I don't need GitHub and Jira or anything like that, but I need something else. So you can implement your own plugin and use them. So we have lots of use cases. So it's easy to set up. You can install DevLake via Docker Compose, Kubernetes, Helm, or Temporary. And we are also coming up with new installation methods. You can check it in our website. And you can collect data using the config UI. It's very simple. You need not know how to code for this one, for the user setup. And once you configure and add a project you want to analyze, you can view the dashboard using Grafana. And you can customize your own metrics using SQL. So if you want to explore DevLake, you can maybe you can show in yours. I'll just finish the presentation. So now we'll talk about Dora metrics, right? So Dora metrics is nothing but it measures the velocity and stability of your development process. Like how many times you are releasing into production, how many times you are deploying. So what is the frequency of that? That is coming under velocity. And how many times the lead time for changes is nothing but when you are creating an issue and committing it, and how much time it is taking for that commit to push into production. So these are the minor things which we need to take care. If you are committing to some open source project and imagine the maintainer is rejecting it, right? Let's say. That means whatever you have invested on that commit is what not useful for a product at the moment, right? At the moment it might be not useful or you have to improve your commit, right? So in the same way for developers, if they don't know what is the priority, then their efforts is going to waste. Like if they're working 8 hours per day on that issue, then that 8 hours per day is not valuable. So as a leader, team leader, you can actually analyze what is more useful by tracking the lead time for changes, right? And change failure rate. So percentage of deployments causing a failure. Like let's say 90% of the deployments in 1 week cause the project or your product to crash. That means it was not up to the mark. The quality was not up to the mark. The stability, basically, right? Stability of the software. When it comes to software, it's all about stability. And mean time to recover. Now, the changes, the failure has happened. Now, how much time it is taking for that failure to fix? So these are called Dora metrics, as simple as it. Right? So now, how to implement Dora metrics? You can actually join our Slack. And also, if you don't want to explore more about Dora metrics, you can explore about the community dashboard, which is already there in our website, where you can maybe, maybe after the event, you can just go home and see how to analyze any open source project and what meaning you get out of it. Like think like you are the maintainer of the project and how you can improve that project. You can propose to the maintainer, right? Hey, we have seen this, so maybe this is something we can fix. We don't see engagement in your community for past 1 month, and before that there was high engagement. So something needs to be done. So if you are into community management, if you are into advocacy or evangelism, you can use Devlink as a tool to understand projects and help other maintainers. So that is also one type of contribution you are giving. So this is the overall introduction for Devlink. Now Shubham would be giving you some insight on how to use and implement your own plugins, right? And also about the dashboards which we have. Yeah.
Now I will show you a general installation of Devlink. So Devlink is a I think you are pretty clear on
Hey Tishan, can you hear me? Hey Tishan, can you hear me?
Yes. Please wait a minute. Let me find my headsets here.
Sure, sure. See,
So,
we'll be starting in 5 minutes because we tried to cover it earlier. So is that okay?
I'm sorry. Please again.
We will be starting in 5 minutes for your slot because we covered little
5
earlier.
minutes. Okay.
5 minutes, right?
Yeah, 5 is perfect. Thank you. I just need to find my headset here.
No problem. Take your time. Yeah. Hey Tishan, you can go live.
Yes, I'm sharing my screen. Can you see it?
Yes.
Okay, because I'm using Keynote and it's full screen. I cannot see anything. Yeah.
Okay, no problem.
You can see the title, right?
Yes.
Okay. I think there is some echo from your side, but it's fine. Yeah. I cannot hear myself, so it's okay. Yeah. Should I start now or wait a minute?
Just wait a minute. We are setting up the sound.
Okay, let me know. Yeah, I'm ready. Yeah.
Hello. You can start Tishan.
Tissing, I think you're mute.
Yeah, we can hear you.
How about now?
Yeah, better
Hello.
now.
Now is okay.
Yep.
How about now? Because I'm using full screen to play this keynote, so I cannot see myself or the status of the meeting. Yeah, everything's fine.
It is fine from my
Okay,
side. Not sure,
great.
Joshua.
Then, Joshua, everything okay?
Yeah, it's perfect.
Okay, thanks for the confirmation. Then I'll start. Yeah. Hello everyone, and today I'm honored to join this Hacktoberfest. I will give a short speech about DevOps, about platform engineering, also about DevStream, and more. First, let me introduce myself briefly. Okay, my name is Tiexin Guo. I'm the chair of DevStream Project Management Committee. Before DevStream, I worked for AWS, Huawei, Oracle, and other big IT companies as well. Yeah. Besides that, I've also done quite some consulting work for Fortune 500 companies like Daimler, Tesco, and so on. Yeah. I've also got some experience in startups as well. And when I'm not working, I enjoy writing blogs. I'm a guest writer for DevOps.com, GitGuardian, and Doppler. I also host a DevOps publication named Fourth Coffee on Medium. Yeah. Okay, enough about myself. Without further ado, let's get started. And we begin with the story of Amazon Web Services, aka AWS. Okay. When AWS started more than 20 years ago, it actually had a monolithic architecture. It didn't start with a microservice architecture. With time goes on, as the monolith grew bigger and bigger, everything became more challenging. It took more time. Um, and work to develop new features, and it's more complicated to deploy, harder to collaborate as well. Then the microservice architecture came to rescue. The idea behind this is simple, because small teams and small products are more efficient. But there also came new challenges with it, because as many teams and services, it was even more complicated than before to build and to ship the product. That is why AWS developed its own tools. For example, some of you might have heard Apollo or AWS Code Pipeline, etc. Yeah, and this is AWS Code Pipeline, which is also available for AWS customers. So if you're using other public cloud services, chances are they all provide their own DevOps platforms. For example, Microsoft Azure and Alibaba Cloud both have their own DevOps services. Yeah. However, there are a few problems with these kinds of like unified DevOps platforms. And today I will walk you through 3 of the major problems one by one. Okay. And the first is the unified DevOps platforms are all like these one-size-fits-all products. But unfortunately, one size doesn't really fit all, right? I think as a generic DevOps platform, it could solve 80% of people's problems relatively well. But still, it cannot solve 100% of people's problems. And it, of course, cannot solve a particular problem perfectly, because each team and each product, they have different needs, right? So if you want the best, one size fits all is not the answer. And the second issue with this kind of unified DevOps platforms is vendor lock-in. Let's still take AWS as an example. If you're relying on AWS Code Pipeline heavily, what if one day you want to use Google Cloud for a hybrid cloud architecture, right? Or maybe you want to move to Microsoft Azure completely. Then you'd have to migrate all your pipelines because apparently you cannot use AWS Code Pipeline in GCP or in Azure. So you are vendor locked in. Last but not least, there is this issue of flexibility. Imagine you just learned from others that maybe GitOps would boost your team's productivity to another level, right? And you knew that open source tools, for example, like Flux CD or Argo CD could help you to achieve this. Okay, you want to integrate them with AWS Code Pipeline, let's say. But it's not easy. Even if it's possible, it's not simple. Or you'd have to wait until the platform actually supports GitOps. Maybe it's next month, maybe it's next year, you never know, right? Okay. You may think maybe you are perfectly happy with this kind of one-size-fits-all DevOps platforms, and you don't really need to use the best tool for every single stage of your software development lifecycle. But actually, that's a little bit dangerous to think like this, because most DevOps initiatives actually would fail. According to this research and analyst firm Gartner, 90% of DevOps initiatives will fail in 2023, which is next year. Fail means fail to fully meet your original expectations. That is why we have to strive for the best to make DevOps worth it. Otherwise, we're just doing it, but it doesn't bring as much value as we hoped in the beginning. Some people may even say that DevOps is already dead, and the next big thing is platform engineering, right? So that's the 3 major issues with this kind of one-size-fits-all platforms. But if the one-size-fits-all platforms they are not the answer, then what is the answer, right? That's a good question. And my answer to that question is open source. Why? Because there are a lot of new open source DevOps tools with excellent community support. Something new emerges from time to time in the DevOps world. If you want the best DevOps and you want to be in the top 10%, you want to be in the top 10 like performing teams, you need the best tools and you need the best platforms for the job. we can maybe still talk about the previous example, which is GitOps. If using GitOps can give you the extra edge, why wait until it's supported by some one-size-fits-all platforms instead of using it right now? Right? That is my answer. Open source, which is the best, right? But with that said, there are actually a lot of challenges using open source tools, building your DevOps toolchain, DevOps platforms. It is actually more challenging than one might think. Here, I'd like to talk to you about maybe two major difficulties of building DevOps engineering platforms using open source pieces. And the first is actually learning curve. For most developers, there is a very steep learning curve for each DevOps tool. You need to know what it is, learn what specific problem it solves, and maybe there are equivalents and alternatives. You need to learn them all and install, configure, use, then compare. Then only then you can reach your own conclusion and choose the best, right? And if the learning problem itself isn't big enough, we need to be aware that one single tool actually doesn't work alone. We need to integrate all the pieces to build a truly functioning, continuous everything DevOps platform. Here I'm using a picture of a disassembled camera, like a camera with a body frame, shutter curtain, display, CMOS sensor, batteries, what have you, right? In the software development lifecycle, there is also project management, issue tracking, continuous integration, continuous deployment, centralized logging, monitoring, distributed tracing, even incident management, and etc. So we need to integrate all of them and automate everything. But only some companies and some teams can have enough resources for these kind of tasks. Not everybody can afford to build a DevOps platform from the ground up, right? And this is the reason we decided to do an open source project called DevStream. So what is DevStream? So in short, DevStream aims to build your own like tailor-made DevOps engineering platform from scratch at the click of a button. The main thing here is tailor-made, right? It's like a la carte. You don't have to order a whole predefined menu. You do it in the a la carte way. You can customize your dinner choices by ordering each dish you want instead of the whole menu. And that's the flexibility DevStream can provide you. Maybe some people will think about Helm. With Helm, you can install different applications, different tools in a Kubernetes cluster. To be honest, in some ways, DevStream is a little bit similar to Helm because it can also manage DevOps tools. But it's more than that. I mean, if you only want to install some tool, maybe just go for Helm. Don't use DevStream. That's not what DevStream is best at, right? So DevStream manages not just tools, but tool chains, focusing on the chain part. So it configures and integrates everything together into a DevOps platform that fits your need precisely. You just need to choose the tools you like and let DevStream handle the rest. Heck, even if you don't know what tools you want to select, DevStream can give you some recommendations. Maybe you can simply pick a template that fits your need the best. It's like every dev's dream, right? Yeah, it's a terrible wordplay, sorry, yeah. So DevStream can create your tailor-made DevOps platforms without coding, without any like manual overhead. But how does DevStream even do that? What's the magic behind that, right? And the thing is, we try to define some DevOps platforms as YAML configurations. And with the click of a button, you can have your DevOps platform up and running in no time. And thanks to the like very flexible core plugin architecture, we can achieve this flexibility because the core of DevStream only acts like a state machine. It only manages the state and it doesn't do anything like else. But each plugin does the create, read, update, delete stuff for the installation, configuration, and integration. Okay. That's basically everything about DevStream. If you are interested in it, maybe you can give it a quick try. Here are some useful links. We have a very passionate community to help you get started as soon as possible. After trying, maybe you even want to create a plugin for DevStream yourselves. In that case, do not hesitate to reach out to us. Okay, now we still have a few minutes to kill. So how about we do a quick demo? Okay. To be honest, I usually don't really do demos in meetups because literally a million things can go wrong, like local development environment, networking, intermittent issues, stuff like that. But still, I'd like to give it a try today. Fingers crossed, and maybe let's go. Yeah. Let me reshare my entire screen for this. Okay, entire screen. Could everyone see my screen?
Yep.
Okay, thank you. Let's maybe start with the very simple configuration of DevStream. So basically, for each like DevOps platform, you define it with the YAML configuration. The main config is relatively simple with only like 3 sections. You specify what tools you want and in which files they are defined, and maybe you can have some variables to make the configuration more flexible. Okay. Then we can have a look at this tools file. Maybe let me make it even bigger and maybe fold it first. So as we can see, we have like 4 sections in the tools config. Basically, what we are going to do is first we will create a repository from scratch, maybe use some template. And this repo will contain some scaffolding code, which is a Python web application. Then DevStream will also try to help you to set up CI pipelines with GitHub Actions. And DevStream will also install Argo CD for GitOps and create application in Argo CD to deploy the scaffolding application. That's the whole thing we are going to do. So 4 sections. Maybe we can look at just one section of the configuration. Basically, we have a name here. And for each tool, we have an instance ID, which is a unique ID. Yeah. Then we have some options. For this plugin, for this tool, there are relatively more options, but for some, there is basically nothing like this one, right? So the whole config file is like, at the moment, like 46 lines of code. And we're still in the middle of like minimizing this config. So maybe in the future, it will be even shorter. That's the whole config. Maybe we can give it a try. Okay. I have already downloaded DevStream locally, which is a command line tool, very simple to use with help. Yeah. And we can just do DTM apply, which will use the config file to create the whole DevOps pipeline and the platform. Yeah. Basically, we can see there are 4 tools corresponding to the config file we just showed. Yeah. Then we easily continue. Yeah. There will be some progress. Maybe this takes 1 or 2 minutes. Yeah. The first step is to scaffold the repo from scratch. Then it will create GitHub Actions for CI pipelines. Sorry. Yeah. Then it will install Argo CD, but it's only install Argo CD itself. At last, it will create Argo CD application, which deploys the app. Yeah. I think this is still installing Argo CD. If we scroll up a little bit, the repo is already created. Now is the second of the 4 steps. Yeah. Okay, so Argo CD is also installed. Third step is GitHub Actions workflow, which is 3 separate workflows. And last but not least is the Argo CD app, which is in charge of deploying the application we just created. Okay, maybe we can do some verification. Let's maybe go to GitHub first. This is my personal GitHub account. If we go to repositories, you see there is a new repo which is created just now. And in this repo, we already have some basic scaffolding code. which is rendered by templates. So it's basically a Python API application. Yeah. We can also see that GitHub workflows is also created. And we have a test for running Python related tests. And we also have a lint for PEP8 check. Then we have Docker build, Docker push. Yeah. If we go to the actions, we can see they are already running and it's already finished. Yeah. Maybe if we can go to Docker Hub, I think the new image will have already been created. Yeah. Need to log in. This is also pushed a few minutes ago, the very first repository, and with a tag, I think it's 0.0.1, which is following the semantic versioning convention. Yeah, so this is also done. And I have a running Kubernetes cluster locally, which is actually running in my Docker container, but it's here. Yeah, and we can see we have a new namespace created, which is Argo CD. And the Argo CD is up and running for already like 2 minutes. These pods are all created by DevStream, so it's running. If we get applications, and we can see this is also created by DevStream, and this application of Argo CD is already synchronized. And if we go to the default namespace, we can see the pod is up and running. Maybe I can even do a port forward hello world locally so that we can actually access this service from our browser right now, localhost 8080. Okay, this single line of text is actually returned by the Python application we just created automatically from scratch with DevStream. Okay. Okay, that's the whole demo. And yeah, if you have any questions, please go. Yeah. Okay, you're welcome. If there is no more question, maybe I can hand this back over to Joshua. Yeah.
Thanks, Station. So I think we can proceed with the next speaker session. I'm sure they're gonna join DevStream community, and we can have some questions or discussions from there.
Okay.
Hey, Jack, you can go ahead with your presentation.
All right, cool. Let me share my screen first. Just a moment.
Hi, Jack. It's not visible.
Yeah, just a moment, please.
Yes, it's visible now.
So, like, could you see the whole slides?
Yes, sure.
All right, cool. Then I'll just start now. Is it cool now? Hey?
Yeah, we
So-
can hear you.
All right, I'll just start. Okay. And hi, everyone. Welcome to my talk. And I'm Jack from RockMQ team at Alibaba Cloud. also a committer from Apache IOTDB. And today I'm going to give you an idea of what RockMQ is and what our community want to achieve in the near future. Hope we could get some great developers to join us and build a community together. So first of all, some background knowledge should be learned. What is the MQ meaning in Apache RockMQ? So here's a classic scenario in the e-commerce website. This is also where RockMQ is mainly used inside Alibaba. Suppose you want to buy a product from the website without the message queue. You may need to wait until the order information being transferred to the server and the result notification being returned from the mail system after processing. And this is pretty time consuming. And once the number of consumers becomes very big, the weaker system like mail system might just crash directly. So after applying the message queue, the data could be temporarily stored in it and returned. Therefore, we do not need to wait until the whole process complete, which you could see. We only need to put the order result into the message queue and we're good to go. This is the asynchronous ability that the message queue provides. After sending data into it, the mail system could just pull the data from the message queue based on its ability, which is able to prevent the system crash directly. And this also allows us to decouple the complex architecture. For example, if we want to add an SMS system to notify consumers of the order processing result, we only need to make it pull the corresponding message from the message queue without changing the business logic within the server. And these are just the basic abilities what the message queue provides. There are much more it could do in the real production environment. Okay, next, back to our main topic. What is RockMQ and what could it do? Here are some core concepts of RockMQ should be clarified. First of all, the concept of producer includes the producer groups and instances. Producer group is a combination of several producer instances, and RockMQ expects those instances in the same group to behave consistently, which means like producing the identical type of messages. And the same goes for the consumer groups and consumer instance as well. And the topic is the classification of messages. All messages in a cluster can be classified by topics, and tag is a subcategory of a topic. The consumer must first assign a topic and then a tag to subscribe messages. So as for the broker includes 4 parts. First, the commit log. The commit log is a regular file storage. The data sent by RockMQ will be appended into it. And the consumer queue contains the consumption progress of each message queue within a topic. And the index allows us to query the message based on the key on the dashboard. And the Delager commit log, which is the commit log managed by the Open Messaging Delager, which could achieve the high availability by Raft. And at last, the name server. The name server is responsible for recording the broker routing information for the producer and consumers to find the corresponding broker. So the whole architecture of RockMQ model is very simple. The producer serves as a data source that optimizes, writes, and publishes messages into one or more topics. It will select the corresponding queue within a broker according to the load balancing result. And like just said, name server is a simple routing registry that supports producer and consumer discovering the routing information of the broker. And after locating the corresponding broker through the name server, the producer will then send messages into it. And the broker will be responsible for the message storage, delivery, query, as well as the high availability. And in the end, the consumer will consume the messages from the broker. So this is the whole process of how RockMQ works. And of course, RockMQ is not only a simple message queue. Besides the basic abilities what message queue provides, it also includes a lot of features. For instance, RockMQ supports several types of messages, such as ordered, transactional, delayed, and batch messages. For the consumer, it supports clustering and broadcasting mode. Clustering mode implies consumers within the same group could consume messages evenly. And the broadcasting mode means that all consumers within the same group are able to consume the same message. Moreover, RockMQ also supports clients in different languages, such as Java, Go, etc. There are much more features of RockMQ, which I could only introduce a small part of it today. Next, I'll make a short introduction of what we are doing and trying to achieve now in the RockMQ community. With the rise of the cloud-native concept, the new generation of RockMQ, RockMQ 5.0, will mainly evolve towards the clouds and trying to build the next generation messaging platform. It had two major changes, including the architecture separating the storage and computing, as well as the lightweight clients. The separation of storage and computing means the brokers will be divided into storage brokers and computing brokers. These two types of brokers perform their own duties and are responsible for storage and computing respectively. And for the client side, our client ecosystem was relatively rich before, but the functions of each client were quite different, making it difficult to achieve consistency. Now, RockMQ 5.0 has solved this problem and implements a lightweight gRPC-based clients with multiple languages. It transfers the previous heavy logic at clients such as load balance to the compute broker. The client only has message consumption and production interface, which makes the client logic be more lightweight. And the community also works on enriching our ecosystem. The ecosystem now evolves several parts. I'll introduce a few key projects here. For clients, it is mainly divided into Java clients and non-Java clients. The Java client is the most native client, which is consistent with the programming language of RockMQ and has the most complete functions. And for the computing part, RockMQ Flink can directly connect with Flink, which is convenient to transfer RockMQ data for computation. And the RockMQ Streams is the lightweight computing framework with simpler and lighter functions. And for the cloud-native part, RockMQ Docker supports packaging RockMQ source code into a Docker image project, which can support packaging on various platforms. And for the RockMQ operator, it has supported the Kubernetes on RockMQ, which could support operations such as starting the clusters or restarting the process, etc. And now I'll show a simple quick start demo here. We only need 3 to 4 steps to achieve the message producing and consuming through the RockMQ. So I'll show it. Show the whole screen here. All right, could you see my screen? Yeah, I just basically started. So here's the simple tutorial, quick start tutorial of Apache RockMQ on our official website. And to do the quick start, the first step, we need to get the Apache RockMQ package on our official website or like on our GitHub here. And you could see on my screen that I already installed the RockMQ on my local machine. So now let's start the second step, which is starting the name server here to allow the broker register to the RockMQ. Just copy and paste the comment. And let's check whether the name server has already started. And yep, in the log, the name server boot success, which means like the name server has already started here. So the third step, we're gonna start the broker here. The broker will work as the message storage, which we could send the data into it. Okay, and let's check whether the broker has already started. Okay, yes, the broker boot success here. Okay, so now we have already run the RockMQ cluster up, and now we're gonna send and receive the message through the RockMQ now. So we first specify our name server address to allow the broker routing information discovery. And now we could start the producer client here to produce a few messages here. And you can see here that we already sent some messages into the RockMQ. They are all stored in the broker. And now we could start a consumer client here to consume the message from the RockMQ here. Yep, here we go. We have already consumed the message that we have sent it into the RockMQ. So like this is just a simple quick start demo here, which you could just download it from our GitHub or official website to try some other features. Okay, so back to our slides here. So the last thing I want to talk about is how a newcomer could make contribution to the RockMQ community. So both in code and non-code contributions are welcome. RockMQ has also joined the Hacktoberfest this year, which means that you can make contributions to our main repos or official website repo to earn the rewards of the event. For the main repo, you could try to find bugs or do some optimizations for the code, and then send an issues or pull request to our GitHub. As for the website, our official English documentation now is incomplete and weak at the moment. You can maybe try to find errors in it or help us do the translation work. Or you could just simply write the corresponding English documents based on our topic. And like just said, we've also got a lot of ecosystem projects. You could randomly pick one and start your contribution journey at RockMQ. Okay, so here are some ways to join our community, which I'll later provide it on the Slack. Since most RockMQ members now are from China, we are trying to involve more developers from different countries or cultures to build an international community, especially for someone who's better at using English. To be short, RockMQ basically has no long-term contributors from outside of China, so we would have more opportunities for those who can enhance our international influence. Thus, So I hope that everyone here today could join our community and build things together with us. And at last, here are some personal contact details of my own. You could find me on any media on this slide. And welcome to discuss with me about how to make RockMQ better or the technical details of the RockMQ. Okay, and that's it for today. And thanks for joining me and hope you have a nice day. And see you later on Slack, maybe, I guess. Okay, then back to Joshua.